January 4, 1945. Kobi Airfield, Formosa. The tropical morning air hung heavy with smoke as Japanese ground crews rushed toward the crashed aircraft, sitting in tall grass near the airfield perimeter. What they found made them forget the artillery fire for just a moment. An F6F-5 Hellcat, largely intact, its dark blue paint barely scratched, the white star on its fuselage still clearly visible. Bureau number 71441 from VF-44, USS Langley. The pilot, Lieutenant Charles V, August, had force-landed after his engine failed during a strafing mission. He was already a prisoner, on his way to a camp near Tokyo, but the aircraft he left behind represented something far more valuable than one captured aviator. For nearly 2 years, Japanese pilots had been sending back increasingly desperate reports about a new American fighter that was systematically destroying their squadrons. The Hellcat had appeared in combat in August 1943, and within months it had fundamentally altered the balance of air power in the Pacific. But intelligence reports and pilot testimony from traumatized survivors in the chaos of combat weren't engineering data. They couldn't tell you compression ratios, wing loading figures, or precisely how the Americans had solved technical problems that Japanese engineers still struggled with. Here, sitting in Formosan grass, was the answer to questions that had been haunting Japanese naval aviation since the Battle of the Philippine Sea. The recovery operation began immediately, even as the battle for the airfield raged around them. Every hour counted. American forces were advancing, and this prize couldn't fall back into enemy hands. By late January, as American bombers continued their relentless assault on Japanese positions, the captured Hellcat was already en route to the Japanese mainland. It arrived at the Yokosuka Naval Air Technical Arsenal, where some of Japan's most skilled aeronautical engineers waited to disassemble it, study it, and understand exactly what they were up against. What they would discover in the wings of that captured fighter would shatter the last illusions about Japanese aviation superiority. The 6 Browning M250 caliber machine guns mounted in the Hellcat's wings didn't just represent superior firepower. They represented an entirely different philosophy of aerial warfare, one built on industrial abundance, pilot survivability, and overwhelming material superiority. The mathematics weren't just unfavorable, they were apocalyptic. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. To understand the psychological demolition that examining this captured Hellcat would inflict on Japanese aviation engineers, one must first comprehend the confidence that existed in Japanese armament philosophy in early 1945, even as the war situation deteriorated catastrophically. For 3 years, Japanese fighter pilots had believed their mixed armament system, combining nimble 7.7mm machine guns with powerful 20mm cannon, represented an optimal balance of weight, ammunition capacity, and hitting power. The Mitsubishi A6M0's armament reflected Japan's entire approach to fighter design. 2 Type 97 7.7mm machine guns mounted in the cowling, synchronized to fire through the propeller arc, provided high rates of fire and plentiful ammunition. Each gun carried 680 rounds, giving pilots roughly 40 seconds of continuous fire at 900 rounds per minute. These weapons, licensed copies of British Vickers designs, were reliable, accurate at close range, and relatively light. The real punch came from 2 Type 99 20mm cannon mounted in the wings, outboard of the landing gear. These weapons, based on the Swiss Oerlikon design, fired explosive shells capable of devastating damage when they connected. Early models carried just 60 rounds per gun, though later variants increased this to 100 rounds. The shells weighed considerably more than machine gun bullets and packed tremendous destructive potential. A single 20mm hit could shred control surfaces, pierce fuel tanks, or kill a pilot outright. This mixed armament philosophy seemed logical in 1941 and 1942. Japanese pilots used the machine guns to find range, walking their tracers onto the target. Once the range was established, they would switch on the cannon for the killing burst. Ammunition conservation was critical. Lieutenant Commander Saburo Sakai, who would become Japan's second highest scoring ace to survive the war, wrote extensively about this technique. The machine guns were for stalking, the cannon were for killing. The system worked brilliantly in the war's opening months. Over Pearl Harbor, the Philippines, the Dutch East Indies, and Singapore, Zero pilots achieved extraordinary kill ratios. The 7.7mm rounds, while lacking stopping power against robust aircraft, proved entirely adequate against the lightly built Allied fighters and bombers of 1941, the American Brewster, Buffaloes, and British Hurricanes that opposed the Japanese advance had minimal armor protection. Against such targets, even light machine gun fire could prove lethal. The 20mm cannon's destructive power was undeniable when shells connected. A burst of 3 or 4 hits could tear a wing off a B-17, obliterate a P-40's tail section, or cause catastrophic fuel tank explosions in unprotected aircraft. Japanese pilots grew confident in their weapons. They believed they possessed the optimal combination of hitting power and ammunition supply for the long-range fighter missions that characterized Pacific warfare. But this confidence masked fundamental weaknesses that would become catastrophically apparent as the war progressed. The Type 99 cannon, while powerful, suffered from relatively low muzzle velocity. At 750 meters per second, the 20mm shells followed a pronounced ballistic arc, making deflection shots at maneuvering targets extremely difficult. Sakai himself noted that shooting down an enemy aircraft with the cannon was like hitting a dragonfly with a rifle. The rate of fire compounded the difficulty. At around 450 to 500 rounds per minute, the Type 99 fired roughly half as fast as comparable American weapons. Combined with the limited ammunition supply, inexperienced pilots often exhausted their cannon ammunition in just 2 bursts. Veteran pilots like Sakai could stretch their ammunition to perhaps 5 or 6 bursts through disciplined fire control, but this required skills that the rapidly declining quality of Japanese pilot training made increasingly rare. More fundamentally problematic was the vast difference in ballistics between the 7.7mm machine guns and the 20mm cannon. The machine gun rounds followed a relatively flat trajectory out to 400 meters. The cannon shells arced significantly more. A pilot zeroed in with his machine guns would find his cannon shells falling short or sailing high. This necessitated constant mental adjustment, calculating separate aiming points for each weapon system during the split seconds of combat. By mid-1943, Japanese pilots were encountering American fighters that their 7.7mm machine guns simply could not damage effectively. The Grumman F4F Wildcat, and then the F6F Hellcat and F4U Corsair, featured armor protection and robust construction that rendered light machine gun fire nearly ineffective. Sakai himself experienced this revelation during a combat engagement with Wildcats, when he poured 500 or 600 rounds of 7.7mm ammunition directly into an F4F, only to watch it continue flying. With his plane in such condition, no wonder the pilot was unable to continue fighting, Sakai wrote. A Zero which had taken that many bullets would have been a ball of fire by now. Preparing and narrating this story took us a lot of time, so if you are enjoying it, then subscribe to our channel. It means a lot to us. Now back to the story. This forced Japanese pilots to rely almost exclusively on their 20mm cannon against modern American fighters, but the limited ammunition supply meant they often found themselves in extended combat with empty cannon, reduced to trying to damage armored American aircraft with essentially ineffective machine gun fire. Pilots returned from missions reporting that they had scored numerous hits without bringing down their targets. The Americans seemed to be flying invulnerable aircraft. Japanese aviation authorities were aware of these problems by late 1943. Attempts were made to address the deficiencies. The A6M5B model, entering production in April 1944, replaced one 7.7mm machine gun with a 13.2mm Type 3 weapon based on a Browning design. This heavier weapon had greater penetrating power and better matched the 20mm cannon's ballistics. Later variants added more 13.2mm guns and eventually increased cannon ammunition to 125 rounds per gun. But these improvements came far too late and in far too small numbers. By the time aircraft with improved armament reached operational units in significant numbers, Japan was fighting a purely defensive war against overwhelming American numerical superiority. More critically, the fundamental problem wasn't just the weapons themselves, but the entire design philosophy they represented. The Zero's armament reflected Japanese priorities: minimize weight, maximize range and maneuverability, trust pilot skill to compensate for any deficiencies. Every gram counted in Japanese design. The entire aircraft was an exercise in weight savings pushed to absolute limits. No armor protection for the pilot, no self-sealing fuel tanks, no redundant systems. The lightest possible structure, and weapons chosen to provide adequate firepower while minimizing weight penalties. This philosophy had produced an exceptional aircraft for 1941, but one fundamentally unsuited to the attritional warfare that the Pacific conflict became. As American pilots learned to avoid dogfighting and instead use high-speed slashing attacks, the Zero's maneuverability advantage became irrelevant, and as pilot quality declined due to catastrophic training losses, the skills required to employ the Zero's limited armament effectively became increasingly rare. By January 1945, when ground crews at Kobi recovered the intact Hellcat, Japanese fighter pilots were largely flying the same aircraft with essentially the same armament that had dominated Pacific skies in December 1941. Minor improvements had been made, but the fundamental design remained locked in place by Japan's limited industrial capacity and the complete disruption of development programs due to constant American bombing. Intelligence reports had told Japanese aviation authorities that American fighters carried 650 caliber machine guns. Some reports mentioned the devastating effect of concentrated American firepower, but numbers on paper couldn't convey the visceral reality of what that armament actually meant in combat. The weight of fire, the penetrating power, the ammunition capacity, the reliability under combat conditions. As the captured Hellcat arrived at Yokosuka and engineers began their systematic documentation, they finally had the opportunity to examine American armament philosophy in detail. What they would discover would confirm their worst fears. The Americans hadn't just built better guns, they had built an entirely different weapon system based on a completely opposite set of priorities. And in the test of combat, American abundance had proven decisively superior to Japanese elegance. The initial walk-around inspection of Bureau number 71441 took days. Teams of specialists examined different aspects of the aircraft simultaneously. Structural engineers focused on the airframe. Propulsion specialists studied the massive Pratt & Whitney R2800 engine. Avionics personnel examined the radio equipment. But it was the weapons team that made the most disturbing discoveries. The 6 Browning M250 caliber machine guns mounted in the Hellcat's wings, 3 to each side, represented a weapon system entirely different from anything in Japanese service. The engineers carefully photographed each gun in place before removal, documenting ammunition feed systems, mounting arrangements, and harmonization methods. When they finally extracted the weapons for detailed examination, the sheer mass was immediately apparent. Each AN M2 aircraft gun weighed approximately 65 pounds, stripped of ammunition. The 6 guns together represented 390 pounds of weapons alone, before considering ammunition, feed systems, and mounting hardware. A single Hellcat's armament weighed more than many entire Japanese trainer aircraft. This was American design philosophy made manifest. Where Japanese engineers counted every gram, their American counterparts simply added mass when it served a purpose. The ammunition capacity stunned the Japanese specialists. Each gun was fed by an ammunition box holding 400 rounds. Total ammunition load, 2,400 rounds of 50 caliber ammunition. At the standard rate of fire of approximately 750 to 800 rounds per minute, this provided roughly 30 seconds of continuous fire. Compare this to the Zero, whose combined armament of 2 machine guns and 2 cannon provided perhaps 12 seconds of mixed fire before the cannon ran dry. But it wasn't just the quantity of ammunition that shocked Japanese engineers. It was the nature of the ammunition itself. The 50 caliber BMG cartridge represented a weapon system of entirely different scale from Japanese machine gun ammunition. where the Type 97 7.7mm round weighed approximately 12 grams and produced roughly 450 joules of kinetic energy at the muzzle, the 50 caliber round weighed approximately 46 grams and generated between 17,000 and 19,000 joules of energy. Let that sink in. A single 50 caliber round carried roughly 40 times the kinetic energy of a Japanese 7.7mm bullet. 4 times the energy, at more than 4 times the weight, meant the 50 caliber round retained energy far more effectively across distance. Where 7.7mm fire became largely ineffective beyond 400 meters, 50 caliber rounds remained lethal beyond 900 meters. The armor-piercing incendiary rounds loaded in the Hellcat's ammunition boxes could penetrate 21mm of armor plate at 500 yards. The Zero's total armor protection was 0mm. A burst of 50 caliber fire wouldn't just damage a Zero, it would obliterate it. The massive bullets would smash through the lightweight structure, shredding control cables, piercing fuel tanks, and destroying vital systems with shocking efficiency. Testing of captured ammunition revealed the mix typically used in combat: alternating ball, armor-piercing incendiary, and tracer rounds in varying patterns. This meant that roughly 1 in 4 rounds would ignite fuel vapor on contact. Against the Zero's unprotected fuel tanks, which had no self-sealing capability, even a brief burst could prove catastrophically lethal. The muzzle velocity of the 50 caliber round, approximately 2,900 feet per second, provided a relatively flat trajectory that made deflection shooting far easier than with Japanese cannon. More critically, all 6 guns fired the same ammunition, following nearly identical ballistic paths. An American pilot didn't need to mentally calculate separate aiming points for different weapon systems. He simply put the gun sight on the target and fired. All 6 guns would strike essentially the same point. The rate of fire represented another crushing advantage. At 750 to 800 rounds per minute per gun, the 6-gun battery could deliver 90 bullets per second. In a typical 2-second burst, the Hellcat would fire 180 50 caliber rounds. The weight of fire alone was staggering. The 6 guns could deliver 6.7 pounds of metal per second onto the target. Compare this to the Zero's firepower. The 2 7.7mm machine guns, firing 900 rounds per minute each, delivered 30 rounds per second of light bullets. Total weight of fire, approximately 0.4 pounds per second. Add the 20mm cannon, firing perhaps 500 rounds per minute combined, for another 17 shells per second. But remember, most pilots firing at a maneuvering target would exhaust their cannon ammunition in seconds, leaving them with just the essentially ineffective machine guns. The Hellcat pilot faced no such limitations. 30 seconds of ammunition meant he could fire extended bursts without concern for conservation. In practice, pilots rarely fired continuously. Short, accurate bursts of 1 to 3 seconds were standard. This meant the typical Hellcat pilot could fire 20 to 30 separate bursts before exhausting ammunition. Japanese pilots, by contrast, had perhaps 6 cannon bursts before being reduced to machine guns alone. The reliability of the Browning M2 system was another revelation. The Japanese engineers test-fired the captured weapons, despite shortages of 50 caliber ammunition forcing them to reverse-engineer their own rounds for testing. The guns functioned flawlessly. No stoppages, no malfunctions. Even after the weapons had been subjected to the stress of forced landing, saltwater exposure during recovery, and rough transport, they operated with mechanical precision. Japanese weapons, by comparison, suffered significantly higher malfunction rates, particularly the 20mm cannon. The Type 99 was temperamental about ammunition quality and sensitive to dirt and moisture. Pilots regularly experienced cannon stoppages in combat, leaving them with just machine guns in the middle of engagements. The Browning M2 had been designed for reliability under combat conditions, field maintenance by crews who weren't specialized craftsmen, and long service life. It embodied American industrial philosophy: build it robust enough that it won't break. World War II, Script, Part 2 Continuation. The mounting system itself revealed sophisticated engineering. The guns were stagger-mounted in each wing, carefully positioned to converge at a specific range, typically 350 to 400 yards. This convergence pattern meant that all 6 guns would concentrate their fire on a relatively small area at combat ranges. Japanese pilots who survived Hellcat attacks consistently reported that American fire seemed to converge with devastating accuracy. They weren't imagining it. The harmonization system was designed specifically to create that effect. The ammunition feed system impressed the Japanese engineers with its elegance and reliability. Each gun used a disintegrating link belt system that allowed smooth feeding without the risk of belt jams that plagued some earlier designs. The belts ran from the ammunition boxes through curved chutes to the guns, a system designed to function reliably even under high G-forces and violent maneuvering. As Japanese engineers compiled their technical reports, the mathematics became increasingly depressing. In every measurable category, the Hellcat's armament was superior. Greater hitting power, more ammunition, higher reliability, easier to aim, better suited to the high-speed combat that characterized 1944 and 1945 operations. The only advantages Japanese weapons offered were lighter weight and, in the case of the 20mm cannon, slightly greater explosive effect per hit. But these advantages were meaningless if you couldn't hit the target or survive long enough to employ your weapons. The broader examination of the Hellcat revealed the same pattern across every system. The aircraft weighed 9,238 pounds empty, more than double the Zero's 4,136 pounds. But that weight brought survivability. Armor plating weighing 155 pounds protected the pilot, oil tank, and oil cooler. The bulletproof glass windscreen was 38mm thick, capable of stopping 7.7mm rounds at point-blank range. Self-sealing fuel tanks prevented the fire deaths that claimed so many Zero pilots. The engine told the same story. The Pratt & Whitney R2800 Double Wasp produced 2,000 horsepower in the F6F-3 model, 2,200 horsepower with water injection in the F6F-5 that sat before them. Compare this to the Zero's Nakajima Sakai engine, 950 horsepower in early models, 1,130 horsepower in later variants. The Americans simply accepted that engines needed to be heavy and powerful. The R2800 weighed over 2,300 pounds. The Sakai weighed under 1,200 pounds. American pilots flew aircraft with engines weighing twice as much because the power output more than justified the weight penalty. This power differential translated into performance that rendered traditional Zero tactics obsolete. Maximum speed of 380 miles per hour for the Hellcat versus 351 miles per hour for the late model Zero. More critically, the Hellcat could maintain control in dives exceeding 450 miles per hour. The Zero experienced control surface freeze above 350 miles per hour. American pilots simply dove away from pursuing Zeros at speeds the Japanese aircraft couldn't match. Climb rate told another story of American superiority. The Hellcat could reach 20,000 feet in 7.5 minutes. The Zero required 12 minutes. This meant Hellcats could gain altitude advantage before combat, attack from above, and climb away after each pass, while Zero pilots struggled to pursue. The boom and zoom tactic that American pilots employed exploited every advantage the Hellcat offered. Dive, shoot, climb away, repeat, never dogfight. Never let the Zero employ its maneuverability advantage. As engineers compiled their findings into formal reports through February and March of 1945, the documents painted a picture of complete American technological superiority. But technology alone didn't explain the catastrophic losses Japanese naval aviation had suffered. The engineers at Yokosuka were scientists and designers, focused on technical specifications. They understood what they were seeing, but the full scope of Japan's predicament required understanding not just the Hellcat's capabilities, but the industrial system that produced it. Intelligence reports reaching Tokyo from multiple sources had been documenting American production figures that seemed to defy comprehension. In 1944 alone, the United States produced 16,731 fighter aircraft. Japan produced 5,474 fighters in the same period. The Americans were outproducing Japan in fighter aircraft alone by more than 3 to 1, while, simultaneously maintaining superior quality in each aircraft produced. Grumman Aircraft Engineering Corporation had been producing Hellcats at peak efficiency since late 1943. At maximum production, the company rolled one Hellcat off the assembly line every single hour, around the clock. Total production would eventually reach 12,275 aircraft by the time the last Hellcat emerged, in November 1945. Mitsubishi and Nakajima combined had produced approximately 10,600 Zeros across the entire war. But raw numbers told only part of the story. The cost per aircraft revealed different priorities. A Hellcat cost approximately $75,000 to produce. A Zero cost approximately $25,000. American observers might see this as wasteful. Japanese engineers examining the captured Hellcat understood the truth. Americans spent more because they could afford to protect their pilots and build for survivability. The extra $50,000 per aircraft bought armor, self-sealing tanks, redundant systems, and superior weapons. It was an investment in keeping pilots alive. Pilot survivability statistics made this investment's wisdom clear. American pilots shot down over the Pacific had a 64% survival rate. Japanese pilots shot down had an 8% survival rate. The Americans had organized rescue services, equipped fighters with radio direction finding equipment and radar homing, and built aircraft that could absorb tremendous punishment and still bring pilots home. Dead pilots, no matter how skilled, couldn't gain experience. Survivors could learn, improve, and fight again. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The training pipeline revealed another massive advantage. By 1945, Japanese pilot training had collapsed entirely. New pilots received 30 to 100 hours of flight time before combat. Many had never fired their weapons except during basic training. They climbed into Zeros with minimal understanding of aerial combat, basic flying skills barely adequate for carrier operations, and almost no experience handling their aircraft under combat stress. American pilots, by contrast, received approximately 600 hours of training before entering combat. They practiced gunnery extensively. They learned tactics from veteran instructors who had survived combat tours and knew exactly what worked against Japanese fighters. They trained in aircraft identical to those they'd fly in combat. By the time they reached the fleet, they were already competent aviators. Their first combat mission wasn't their first experience with their aircraft. This training differential, combined with the Hellcat's superiority, produced kill ratios that approached the absurd. The overall Hellcat combat record documented 2,140 aerial victories against 189 combat losses, for a kill ratio of 11.3 to 1. Against Zeros specifically, the ratio was even more lopsided. 1,562 confirmed Zero kills for 124 Hellcats lost to Zeros, for a kill ratio of 12.6 to 1. The Battle of the Philippine Sea on June 19 and 20, 1944, demonstrated what these advantages meant in practice. American pilots would later call it the Great Marianas Turkey Shoot, and the name was apt. Japanese Vice Admiral Jisaburo Ozawa had assembled 5 fleet carriers and 4 light carriers, supported by battleships and cruisers. His force included approximately 430 to 450 aircraft, mainly A-6M-0 fighters, D-4Y Judy dive bombers, and B-6N Jill torpedo bombers. Opposing him, Admiral Raymond Spruance and Admiral Mark Mitcher commanded Task Force 58, with 15 aircraft, carriers, 7 battleships, 11 heavy cruisers, and numerous destroyers. Nearly 900 carrier-based aircraft stood ready, including hundreds of F6F Hellcats. More critically, the American force had operational radar that provided early warning of incoming Japanese strikes. On the morning of June 19th, Ozawa launched 4 massive waves of aircraft against the American fleet. Radar detected them coming. Hellcats were launched and vectored to intercept. What followed was slaughter. Wave after wave of Japanese aircraft met coordinated Hellcat interceptions. The Americans held every advantage. altitude, position, early warning, superior aircraft, better training, and overwhelming numbers. By the end of June 19th, Japan had lost approximately 300 aircraft with their irreplaceable trained pilots. American losses were minimal. The following day, American forces launched a counterstrike against the Japanese fleet. The carrier Hyo was sunk. The remaining fleet suffered heavy losses. Over 2 days, Japanese forces lost close to 480 aircraft. American losses totaled 123, most lost during the long-range strike when aircraft ran out of fuel returning to their carriers. The battle effectively destroyed Japanese naval air power. The loss of hundreds of aircraft and pilots left Japan unable to wage large-scale carrier warfare. But more devastating was the loss of the remaining veteran aviators who had survived the attrition of 1943 and early 1944. These men, many with over 1,000 hours of flight time and combat experience dating back to China, could not be replaced. Japanese pilots who survived encounters with Hellcats returned with consistent reports. The American fighters were faster, more powerful, more heavily armed, and seemingly invulnerable to damage. They attacked in large numbers, from altitude, with devastating effect. They didn't dogfight. They didn't give Japanese pilots the opportunity to employ the Zero's maneuverability advantage. They simply dove, fired, and climbed away, repeating the tactic until the Japanese aircraft were destroyed or the pilots fled. By late 1944, standing orders prohibited Japanese pilots from engaging Hellcats unless holding 3-to-1 numerical superiority. Even then, pilots were instructed to make one pass and disengage if unsuccessful. Tactical directives distributed to Japanese squadrons in late 1944 acknowledged complete inferiority. Never attempt to outclimb a Hellcat, never attempt to dive away from a Hellcat, never engage in head-on attacks. Their armament is superior. Never fly straight and level for more than 20 seconds. Attack only when holding overwhelming advantage and surprise. These instructions were survival tips for pilots in obsolete aircraft. By early 1945, Japanese fighters flew missions knowing they were outclassed in every measurable way. Maintenance had collapsed, fuel quality had deteriorated, spare parts were unavailable. Pilots flew aircraft that hadn't been properly serviced in months, burning 87-octane fuel instead of the required 91 or 100 octane, with ammunition loads reduced to save weight. American Hellcat squadrons, by comparison, enjoyed overwhelming advantages in every aspect of operations. They had radar direction-finding equipment that guided them to targets. They had excellent maintenance from trained crews with adequate parts supplies. They had regular rotation schedules that sent pilots home after completing tours, preventing the burnout that affected Japanese aviators who flew until they died. They operated from fleet carriers with catapults, arresting gear, and damage control systems that Japanese carriers couldn't match. The captured Hellcat at Yokosuka represented not just superior technology, but a complete systems approach to naval aviation. The aircraft itself was formidable. The weapons were devastating. But the real advantage was the entire system. Production, training, logistics, maintenance, tactics, and industrial capacity. Japan had built exceptional individual aircraft. America had built an aviation system that crushed individual excellence through overwhelming material superiority. Senior Japanese officers examining the Yokosuka reports faced uncomfortable truths. The engineers had done their job professionally and thoroughly. The captured Hellcat had revealed exactly why American fighters dominated Pacific skies. But understanding the problem didn't provide solutions. Some problems, once you understand them fully, reveal themselves to be unsolvable with available resources. By March 1945, Japan's strategic situation was brutally simple. Approximately 5,000 aircraft of all types remained, most obsolete, many grounded for lack of fuel or spare parts. American forces approaching Okinawa could call on thousands of carrier aircraft plus land-based air power from captured island bases. The ratio wasn't just unfavorable, it was apocalyptic. The armament analysis particularly devastated Japanese aviation authorities. They had always known American fighters carried heavier weapons, but the captured Hellcat made the disparity visceral. 6 machine guns that individually outclassed any Japanese weapon, fed by ammunition supplies that dwarfed Japanese capacity, mounted in an aircraft that could absorb punishment and keep fighting. It wasn't a fighter. It was a flying battle platform designed to methodically destroy anything that opposed it. Some Japanese engineers advocated for immediate design changes to match American armament philosophy. Install more 13.2mm machine guns, increase ammunition capacity, accept weight penalties in exchange for firepower. But such changes required time Japan didn't have, production capacity that didn't exist, and raw materials that were no longer available. The naval blockade had choked off access to the resources needed for aviation production. Factories that remained operational faced constant American bombing. The development programs that might have produced competitive fighters in 1946 or 1947 were irrelevant. The war would be over by then, one way or another. The most advanced Japanese fighters under development, aircraft like the J-2M Raiden and the Kawanishi N-1KJ Shiden, showed promise on paper. But production numbers were pitiful. Performance was barely competitive with American designs from 1943, and pilot quality had declined so catastrophically that even excellent aircraft couldn't change outcomes. The kamikaze program, which had begun in October 1944, represented the ultimate admission that conventional air combat was no longer viable. If Japanese pilots couldn't defeat American fighters in air-to-air combat, perhaps they could damage American ships through suicide attacks that required no advanced flying skills. The program was born of desperation, not tactical genius. It acknowledged that Japan had lost the air war. Examining the captured Hellcat in spring 1945, Japanese engineers understood they were studying the weapon that had destroyed Japanese naval aviation, not through some secret technology or innovative design, simply through systematic application of industrial might, protected pilots, reliable equipment, and overwhelming firepower. The Americans had built a fighter that good pilots flew well, and average pilots could still employ effectively. They'd produced it in quantities that ensured numerical superiority. They'd trained pilots thoroughly and protected them with armor and self-sealing tanks. They'd armed it with weapons that obliterated lightweight Japanese aircraft in seconds. The 650 caliber machine guns weren't just superior weapons. They were symbols of completely opposed philosophies meeting in combat. Japanese design philosophy: achieve maximum capability through minimum resources. American design philosophy: solve problems through overwhelming material application. When these philosophies collided over the Pacific, material abundance proved decisively superior. World War II, script, IMNOCC, Part 3 Final Warrant Officer Hiroyoshi Nishizawa, who would become Japan's leading ace with 87 confirmed victories, had written to his younger brother in February 1943 about the Zero. The Zero is the perfect weapon, harmonizing with the pilot's spirit like a samurai's sword. The Americans build flying trucks, heavy, clumsy, without soul. By 1945, Nishizawa was dead, shot down in November 1944 while flying as a passenger in a transport aircraft. The poetic philosophy he'd espoused had collided with industrial reality and lost. The Hellcat, sitting at Yokosuka through the final months of the war, became a silent witness to Japan's collapse. By summer 1945, the engineers who had so carefully documented every aspect of the fighter had moved on to more desperate work. They analyzed wreckage from B-29 raids, attempted to develop countermeasures for the firebombing campaign burning Japanese cities to ash, and scrambled to prepare defenses against the expected invasion. The technical reports they'd compiled gathered dust as strategic realities overtook technical analysis. Understanding why you were losing didn't matter when the war was already lost. The 650 caliber machine guns they'd examined so carefully, the ammunition feed systems they'd photographed, the harmonization methods they'd documented, all of it was interesting from an engineering perspective, but operationally irrelevant. Japan couldn't build Hellcats. Japan couldn't even build competitive fighters in sufficient numbers. The war would end not through technical innovation, but through atomic bombs and Soviet invasion. American forces discovered the captured Hellcat, when they occupied Yokosuka Naval Arsenal in August 1945 after Japan's surrender. The fighter sat among dozens of other captured and indigenous Japanese aircraft, all tagged with Japanese technical documentation. American intelligence officers found it somewhat surreal. Here was one of their own fighters, painstakingly disassembled and analyzed by the enemy, its every component photographed and measured. The Japanese technical drawings were remarkably thorough, showing an understanding of the Hellcat's design that rivaled Grumman's own engineering documentation. The armament analysis particularly impressed American observers. Japanese engineers had correctly identified every advantage the .50 caliber weapon system offered. They'd accurately calculated the weight of fire, analyzed the ballistics, tested the ammunition, and drawn the correct conclusions. They simply hadn't been able to do anything about it. Bureau number 71,441 was eventually shipped back to the United States. Charles August survived the war, one of the few naval aviators to be captured twice. He'd previously been held by Vichy French forces after being shot down during Operation Torch in North Africa. His Hellcat served American intelligence for a time before being scrapped. The Japanese reports on the aircraft remained in archives, a detailed record of an enemy who understood exactly why they were losing, but lacked the means to change the outcome. The broader statistics that emerged after the war revealed the impossibility of Japan's position. The United States in 1944 possessed 8 times Japan's economic output, measured in GDP. Industrial production ratios were even more lopsided. Steel production, roughly 10-1 in America's favor. Aluminum production, approximately 20-1. Oil production, essentially infinite to 1, given that Japan's fuel came entirely from captured territories and stockpiles, while America produced millions of barrels domestically. Aircraft production told the story most clearly. In 1944, the United States produced 100,752 total aircraft of all types. Japan produced 28,180. American fighters alone exceeded total Japanese aircraft production, and American aircraft were, on average, more capable, better armed, more survivable, and better maintained than their Japanese counterparts. The loss statistics documented the human cost. By war's end, Japan had lost approximately 25,000 naval aviators. The United States lost 8,950 naval aviators in the Pacific Theater, but the composition of these losses revealed the true tragedy. Japan lost 90% of its pre-war trained pilots by mid-1944. The United States never lost more than 15% of its experienced pilot cadre at any point in the war. This difference in pilot survivability stemmed directly from design philosophies. American aircraft, like the Hellcat, protected pilots with armor, self-sealing tanks, robust structures, and reliable equipment. Japanese aircraft, like the Zero, sacrificed protection for performance. In a short war, this might have been acceptable. In a war of attrition, it was catastrophic. Every loss removed a trained pilot permanently. American losses, when pilots survived being shot down, removed them only temporarily. The Hellcat's 650 caliber machine guns, examined so carefully at Yokosuka, represented this philosophy perfectly. They were heavy. They consumed ammunition at high rates. They required robust mounting structures and sophisticated feed systems, but they protected pilots by giving them overwhelming firepower that could destroy enemy aircraft before those aircraft could inflict damage. The extra weight was an investment in survival. Jiro Horikoshi, designer of the Zero, reflected after the war, "I created a fighter for a nation that lacked resources. The Americans created a fighter for a nation with unlimited resources. My design was an elegant solution to poverty. Theirs was a powerful expression of abundance. In war, abundance wins." Horikoshi understood that the Zero had been optimized for Japan's actual industrial and economic capacity. Given the constraints he faced, he'd produced an exceptional aircraft. But constraints that produce elegant designs don't win wars of attrition. The lessons Japanese aviation learned from the captured Hellcat extended far beyond the immediate military context. In the post-war period, as Japan rebuilt under American occupation, These lessons shaped the entire approach to industrial development. The engineers who had examined Bureau number 71441, who had measured its weapons and calculated its performance, carried those insights into civilian industry. Technology trumps tradition became a fundamental principle. No amount of pilot skill, warrior spirit, or dedication to Bushido could overcome inferior equipment. Quantity has its own quality. Mass production of good aircraft, like the Hellcat, beat limited production of excellent aircraft, like the early Model Zero. Survivability matters. Dead pilots or dead workers or failed businesses cannot gain experience and improve. Industrial capacity determines capability. The nation with the best factories wins, in war and in peace. Innovation pace matters more than initial advantage. Static superiority becomes inevitable, inferiority as opponents improve. The Zero had been superior in 1941. By 1943, it was merely competitive. By 1945, it was obsolete. American fighters evolved rapidly throughout the war, incorporating combat lessons and technological advances. Japanese designs remained largely frozen due to limited development resources and industrial disruption. These principles became founding elements of post-war Japanese industrial policy. The focus on manufacturing quality, continuous improvement, just-in-time production, and worker protection that characterized Japan's economic miracle all reflected lessons learned in the hardest possible way. The engineers who examined the Hellcat understood that industrial success required systematic application of resources, protection of valuable personnel, and relentless focus on improvement. The captured Hellcat's most enduring legacy wasn't military, it was industrial. The same nation that had built Zeros optimized for weight savings and resource efficiency became the nation that built reliable automobiles, sophisticated electronics, and precision machinery characterized by quality and longevity. The philosophy shifted from making do with limited resources to building the best possible products through systematic application of engineering principles. American occupation forces found the Japanese remarkably receptive to learning American industrial methods. This wasn't merely defeated enemies accepting victors' terms, it was recognition that American methods worked. The proof sat in hangars throughout Japan, captured American aircraft that Japanese engineers had examined in detail. The Hellcat with its 650 caliber guns, the Corsair with its powerful engine, the B-29 with its sophisticated systems, all represented industrial and engineering philosophies that had proven superior in the ultimate test. The broader lessons about aerial warfare shaped post-war fighter development globally. The mixed armament philosophy that had characterized early war fighters largely disappeared. Most post-war jet fighters adopted uniform armament systems, whether all guns or all cannon, learning the lesson that ballistic uniformity made aiming simpler and combat more effective. The principle of protecting pilots became universal, with armor, ejection seats, and reliable equipment becoming standard features rather than optional luxuries. The dominance of the Hellcat and its 6-gun armament taught American designers lessons that shaped Cold War aviation. The F-86 Sabre carried 650 caliber guns. The F-84 Thunderjet carried 650 caliber guns. When American designers finally moved beyond 50 caliber weapons, they adopted 20mm cannon in similar numbers, maintaining the principle of overwhelming firepower through multiple weapons of the same type. But the most profound impact was psychological. The Japanese pilots who encountered Hellcats in combat, who survived to return with reports of invulnerable American fighters, experienced one of the most complete reversals in military history. They had entered the war believing in their superiority, technological, spiritual, and tactical. They discovered instead that they were flying obsolete aircraft, following outdated tactics, and facing an enemy with unlimited industrial capacity. The 650 caliber machine guns didn't just shoot down Zeros. They shot down an entire worldview. They proved that industrial capacity trumped warrior spirit. They demonstrated that technology defeated tradition. They showed that protecting pilots was more important than saving weight. These lessons, learned at terrible cost over Pacific waters, helped transform Japan from a militaristic empire into one of the world's most successful peaceful democracies and industrial powers. The Hellcat that Japanese pilots captured on January 4, 1945, that ground crews recovered from Formosan grass, that engineers examined at Yokosuka, that American forces discovered after the surrender, became paradoxically an instrument of Japan's rebirth. By demonstrating the absolute superiority of industrial democracy over militaristic tradition, the captured fighter helped set Japan on a path toward becoming one of America's strongest allies and most successful economic partners. The pilots who survived their encounters with Hellcats carried forward hard-won wisdom. In the modern world, the nation with the best technology and most efficient production wins, whether in war or in peace. The engineers who examined the 650 caliber guns understood that success requires systematic application of resources, protection of valuable personnel, and continuous improvement. The industrial leaders who rebuilt Japan after the war applied these lessons to create an economic powerhouse. Bureau number 71441 served one final purpose before being scrapped. It taught an enemy that understanding why you're losing is only valuable if you can apply those lessons. Japan couldn't, not during the war. The material gap was too large, the industrial capacity too limited, the timeline too short. But in peace, with American assistance and guidance, Japan could apply everything learned from examining that captured fighter. The Hellcat's 6 guns, which had obliterated Zeros in seconds during combat, which had shocked Japanese engineers during examination, which had confirmed Japan's worst fears about American firepower, ultimately served peace rather than war. They demonstrated principles that, properly applied, build successful economies. Quality matters, workers are valuable assets to protect, continuous improvement is essential, and industrial capacity determines outcomes. The complete statistical record of Hellcat versus Zero combat tells a story of total American dominance. Hellcats claimed 1,562 confirmed Zero kills for 124 losses to Zeros, a kill ratio of 12.6 to 1. Overall, Hellcats destroyed 2,140 enemy aircraft while suffering 189 combat losses, for a kill ratio of 11.3 to 1. American pilots shot down who survived, 64%. Japanese pilots shot down who survived, 8%. These numbers document not just superior equipment but superior systems. The Americans protected pilots, with armor and self-sealing tanks, trained them thoroughly, armed them devastatingly, maintained their aircraft excellently, and organized rescue services that brought them home. The Japanese asked pilots to overcome equipment deficiencies through skill and dedication, sent inadequately trained replacements forward as losses mounted, and watched their aviation arm bleed to death. The captured Hellcat at Yokosuka, with its 650 caliber machine guns carefully examined and documented, represented everything Japan lacked and everything America possessed in abundance. Firepower, industrial capacity, systematic approach to problems, pilot protection, material superiority. In examining that aircraft, Japanese engineers were really examining the reasons for their defeat. Sometimes understanding the problem is the cruelest knowledge of all, because it forces you to watch defeat approaching with perfect clarity and no ability to prevent it. That captured Hellcat taught Japan that lesson more thoroughly than any battle ever could. But it also taught lessons that, properly applied in peace, helped build one of the world's most successful economies. The fighter itself is gone, scrapped decades ago. But the lessons remain. Industrial capacity matters. Technology trumps tradition. Protecting valuable personnel pays dividends. Quality improves through systematic application of engineering principles. Continuous improvement prevents obsolescence. These insights, learned from 650 caliber machine guns examined in defeat, helped shape a nation's path forward in peace. The Japanese pilots who captured a Hellcat and admitted its weapons obliterated Zeros in seconds were acknowledging more than tactical inferiority. They were acknowledging that their entire approach to warfare had been wrong from the beginning. The Americans didn't win through superior spirit or greater dedication. They won through systematic application of industrial might, protected personnel, reliable equipment, and overwhelming firepower. That lesson, learned at terrible cost, proved more valuable in peace than any number of tactical victories in war. The nation that built elegant fighters optimized for poverty became the nation that built quality products characterized by reliability and longevity. The engineers who examined those 6 guns learned that abundance, properly applied, beats elegance every time. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.